Okay, day one of 5.2 really had three things that we looked at. So we looked at using the laws of exponents, like you see at the beginning part of that worksheet. Using your laws of exponents, when you have a power to a power, you multiply the exponents. When you're multiplying like bases, you add the exponents. When you're dividing, you subtract the exponents. And the only difference is now they're fractional exponents, so you had to just make sure you know how to work with fractions. And you can use a calculator if you need to do that. So all of these first problems all dealt with just laws of exponents. The second thing we wanted to see that you could do is you could multiply radicals. And that really came to help us later when we learned how to break them up. So when you take and multiply two radicals, we need to know what to do, and then if it simplifies or not. Some of these might have simplified, some may not have. And then the last thing you needed to be able to do is you needed to be able to add radicals, which just means really you're adding like terms. Okay, so I just want to go through a couple different examples of those three properties: laws of exponents, multiplying radicals, and adding radicals. So let's start with laws of exponents. So with the laws of exponents, I just need to make sure if you have any base, I'll just do a base of 3, and let's do 2/3. If you have any base, the property, and you're multiplying them, the property says you keep the base, you add the exponents. So you need to be able to take -1/2 plus 2/3. Now, you should be able to do that without a calculator. You need to get a common denominator, which is 6, and add them together. But let me just show you how to use your calculator to do that. So to use your calculator to add those two fractions together, just take -1 divided by 2, hit plus 2 divided by 3. So all you're doing is thinking of the fraction as a division. When you hit enter, you get a decimal. So if you want to see what that is as a fraction, because we want to keep it as a fraction, you're going to hit the math button, which is right here, the math button. When you hit the math button, you'll see this screen, and you're just going to hit enter to convert it to a fraction. So it converts to 1/6. So you can use your calculator, just add your fractions together when you get your decimal, and then go math, convert to fraction. So this would be 3 raised to the 1/6 power. If you're dividing, so like if I had 5 to the 2/3 divided by 5 to the 1/2, now I would just subtract the two exponents. Keep the base of 5, and then on my calculator I would take 2/3 minus 1/2 and convert that back to a fraction. And it looks like I get 1/6 for that one as well. Okay? Now, a power to a power, let me do that one over here. If you have something like x to the 2/3 raised to the 1/5 power, now you multiply. And again, you can use your calculator, take 2 divided by 3 times 1 divided by 5, or you can just multiply straight across with fractions. You don't have to get a common denominator. So I'm going to take 2 times 1 in the numerator, 3 times 5 in the denominator, 2/15. All right. Now, if it tells you you have to convert that back to a radical, we also learned how to do that in section 1. I would write that as the 15th root, because the denominator is 15, 15th root of x squared. So if they tell you it has to go back into a radical, you can do that after you use your laws of exponents. Same with this one. This could be the 6th root of 5 to the 1st power, or just the 6th root of 5. And this would be the 6th root of 3. So you have 3 properties that you have to work with laws of exponents. And then if it's multiple things happening, like if you have one that gets a little bit tougher, that it's x to the 2/3, y to the -1/2 over x, y to the, 2/5, all raised to the 1/2 power. You have some options. You either can raise each one to the power first, so you're just going to multiply, or you can say that you want to simplify what's in here first, so you can subtract the exponents. It really doesn't matter. Let me just raise each one to the 1/2 power. So if I take 2/3 times 1/2, I'm going to get 2/6, which reduces to 1/3. Y to the 1/2 times that, I'm multiplying the exponents, I get -1/4. Down here I get x to the 1/2. And here when I multiply, I get 2/10, which would be y to the 1/5. So you simplify that first, and now you subtract. So again, you can use your calculator, take 1/3, 1 divided by 3, minus 1 divided by 2, and convert it back to a fraction. And you get negative 1/6. And for the y's, if you take negative 1/4 minus 1/5, you get negative 0.45, but you convert it to a fraction, you get negative 9/20. And then remember, if anything's a negative exponent, after you subtract numerator minus the denominator, then you need to put it into the denominator. So any negative exponent goes down into the denominator and it becomes a positive exponent. So there would be my final answer if I didn't say I had to put it in radical form. Okay? So those are the properties of logarithm or of exponents. You have to make sure that you know those. We talked about those before, like in section 1, but now we're just using fractional exponents with that. Okay, so that's really nothing new. The multiplying radicals is really pretty easy as long as the base is the same, or the root is the same, I should say. As long as the root is the same, you can multiply them. So the square root of 3 times the square root of 7 is the square root of 21. That's really all you need to be able to do. Now with some of them, we had things like the square root of 2 times the square root of 8. And when we put them together, we get the square root of 16. But on the first worksheet, a lot of those came out nicely. So like the square root of 16, I would reduce and say it's actually 4. Square root of 21 doesn't come out nicely, and there's no perfect square that goes in there. So it just has to stay as the square root of 21. But if you multiply, and it's something you can simplify, you should do that. And that's really all that second part of day 1 was. Can you multiply them together? Then the third part is adding. So adding is like adding like terms. So if you have 2 square root of 5 plus 7 square root of 5, well, it's just like having 2x plus 7x. When you put them together, how many do you have? You have 9 of those. So 9 square root 5s. It works with cube roots. If I have the cubed root of x minus 4 cubed root of x, as long as what's underneath here, and even I could have xy squared, but just as long as this whole term is the exact same thing as that whole term, then they're like terms. So over here I have one of them because there's nothing in front of it, so there's one of those terms minus 4 of those terms. Because they're the same, I can put them together. I get negative 3 of those terms. And so I get negative 3 cubed root of x y squared. Okay, so the adding, I think, is a little bit easier. Just make sure they're like terms. If they are, you can add them together. And then the multiplying is just, you're just multiplying. As long as the roots are the same, you can multiply them together. If this would have been the cubed root of 7, nope, I have to leave it as the square root of 3 times the cubed root of 7. But if they have the same root, we can multiply them together. And then the other piece was all the properties of exponents. So if you're a little shaky on the property of exponents, then when we added fractions, it probably got a little bit tougher. But realize that don't make the fractions be what you can't do. Make sure you use your calculator and take negative 1/2 plus, because you're adding them, 2 divided by 3, and then just make sure you can convert it back to a fraction. And if they ask you to put it in radical form, we should also know how to do that. So that was day 1. Those 3 skills you have to be able to do when we're working with fractional exponents.